Hello, welcome to our project, Predicting Stock Prices with Visual Transformers. My name is David Baines, and I have Peter Kinder here with me. The motivation for the project is actually quite simple. The idea is, could we use some of these novel machine learning or deep learning techniques to predict stock prices, even at some short time in the future, such as a month out? The reason why this is an interesting problem is that given the amount of data in financial data, you think this would be relatively simple. But in fact, in financial data, there is so little signal and so much noise that a lot of these techniques actually fall short to deliver promising results. We found basically a piece of the literature that instead of using prices as numerical data, they're actually using prices as visual data called a spectrogram, which you can see on the mid left there. And the idea is that you can use that spectrogram to be a training component in the model, much like we've seen before with CNNs, for example. And hopefully, in this new kind of modality, we could get better signal to noise ratio and be able to predict stock prices a bit more effectively. To speak more about the experiment design and the data that we used, I'll toss it over to Peter.
So the experiment design was based on backtesting over the S&P 500, three different model architectures, which were the VIT alone, the LSTM alone, and the multimodal combination of the two. We were testing this over a decade with each model using the previous 2 years of data as a training set. The time series included the adjusted closing price and volume of a stock, as well as the adjusted closing price of the S&P 500 index and the VIX for context. Each time series was 80 trading days and predicted 20 trading days out, whether the price was higher or lower than the last trading day. All of the time series were then min-max normalized over their individual spans. And for the VIT model, the time series were converted into spectrograms, which is kind of the novel part of this project. What's going on here is a continuous wavelet transformation using a complex Morley wavelet, which is essentially a form of signal extraction being performed on these numerical time series. An analogy is if you have a B note in a song and you do a continuous wavelet transformation with the signal of the actual song, it's good for extracting where that B note occurred in the actual song. And so this resulted in four RGB arrays, which were then concatenated into a 12-channel RGB array. And this was used in the VIT portion of the models. For the LSTM model, it was just the four numerical time series. And for the multimodal model, we used both of these inputs. So if we go over to the summary of the results, we have the setup of the validation accuracies. And what we were doing with this was we were training out a fixed number of epochs and saving three model types. We were saving the last model, we were saving the model with the min val loss, and then we were saving the model with the max val accuracy. And as you can see from a lot of these charts, we're talking accuracy in the mid 80s, which if we could predict with accuracy 20 days out a stock's price, we thought we could be rich men. But as we move to out of sample testing with our models, this is pretty typical in this space. We got a taste of reality, as I'll let David discuss.
Yeah, basically what happened was when we tested this out of sample, we got an accuracy around 50%. And you recall that we're trying to predict if the stock price is going to go up or down, a binary result. And an accuracy of 50% basically means it's a coin flip. So didn't perform that well out of sample, unfortunately. That said, future research can indicate that we could, instead of just using prices, we could also use economic data, for example, to inform the model and pull more signal from the noise. And some of the challenges that we came across was just the sheer abundance of data that we had to train on. Eventually, we actually had to, instead of using 10 years, only use 2 years of training data. And because of that, maybe we're losing a bit of a generality in our auto test or out of sample testing. So those are the areas we're going to continue to look into. But hopefully you enjoy the project. And thanks so much.